Welcome to Industrial PLC Applications. This video is on counters, and it's part of the counters series, and it's part 2, countdown counters. The first counter we dealt with was a count up instruction. What if you need to monitor a depleting resource, such as some of your consumable inventories? You need a counter that will subtract 1 from the current value and turn on an output when the counter value equals 0. You need a countdown counter. Countdown counters have the following input variables. They have the .cd. This is the input monitored and activates a count with a false to true transition. However, it shall not count again until the .cd returns to false, and that is monitored by the internal pulse. They also have the load, which is a Boolean input. This value is monitored to reload the counter. So when the CD_1 load goes from false to true, the programmed value is copied into the current value. And finally, the other input we have is the value that we type in for the program variable, and it is the upper limit or starting point of the count. The countdown counter has the following output variables and parameters. The primary one is the Q, so that would be the countdown_1.Q, and the output is energized when the countdown current value is equal to 0. The countdown value itself, for the current value, is the output variable of the current value, and it's the accumulated decrementing count. The accumulated value of .cd cannot exceed the program value or be lower than 0. Just like the count up counter's reset, the load must be a bool data type to trigger the instruction to top up the current value. And the program value must be a DINT by default. So we have a countdown counter, and right now the Q is turned on because our current value is 0. And what we need to do is we've got to get the current value to equal our program value. Now that's kind of normally the way timers work, that you want the two to be equal. And this time we want to actually make it equal. We want this 10 to leap into here. To do that, we need to use this load. So to make the load energize, we just have to toggle our input 22. And you can't leave it on. If you leave it on, it doesn't perform anything. It has to see that false to true to false transition to actually copy the 10 and load it up into our current value. Notice that the entire time our input was true and nothing has changed, because again, it needs to see the count up and count down bits have to see that the input goes low before it will start registering and looking for that false to true rise. So we'll turn that off. We're going to now click on it, off and on, and you can see that our current value has subtracted by 1. Now the thing about the countdown counters is they cannot count below 0. You can actually write a program value of a negative number, but the instruction does not have an underflow bit. In older PLCs, they would have an overflow bit and an underflow bit to say that I've gone through the entire 32,767, and now I have gone over, so it said the overflow bit, and if it counted down and went below 0, you would have an underflow bit. So I've now wiped this out to 0. My queue is back on. I have to turn my input off. It does not affect my queue because my process variable was 10 and we have eliminated it to 0, which means it's counted down as far as it can go. So what we're going to do is we're going to hit our 22 off and on, and we've reloaded it. So remember, on the countdown timer, the direction of travel, if you will, of information is we take the program value and we insert it into the current value. So let's quickly watch this through the eyes of the variable monitor. So right now we do not have anything counting up or counting down. We do have 10 in our program value and also 10 in our current value. So I'm going to take my 1 to 1, toggle it off and on, and notice here that this pulse is looking for that false to true and acknowledges the complete cycle. If I press 21 again, you can see that the check mark is made. It's now saying, okay, I've seen a false to true transition, but I need to see that true go false again before I'm going to allow it to trigger again. Second, I take that away, it sets that, and that triggers it and sets it up for the next subtraction. And as we go through, you can see it's double checking and verifying. At the same time, you can see the countdown bit up here changing state. Now I'm at 0 and I can press that and you can see that my countdown is true and my pulse is true, waiting for that complete turnaround, but I'm at 0, I cannot go below 0. So let's load this up. I'm going to turn on digital input 22. And you'll see that the load was checked, that it saw the false to true transition. So it said, okay, we're going to take the process variable, the program value, and I'm going to put that into the, that was strange, I'm going to put that into the control, the current value. Okay, so we're going to do a comparison between the countdown counter and the count up counter. I have made some inputs the same so you can watch the two at the same time. So our load and reset are both 22, and I'm going to press the 22, and you can see there was no change on the bottom because we're looking to count from 0 and up. Whereas on the countdown, we need to load 10 to count down to 0. So as I toggle the inputs, one is decrementing, one is incrementing. And when this started at 10, it's now 0. This started at 0 and is now at 10. So both of the cues are on. So to summarize, countdown counters start from a known value and start to work towards 0. They cannot count below 0. They cannot count negative numbers. When you look at the two between a count up counter and a count down counter, count up counters need to have their current values zeroed out before you can start to count up. Count down counters require their current values to be loaded up. So one is reset and one is loaded. In our next video, we're going to look at the combination of the two, or as I like to think of it, how to use a PLC to balance your checkbook.